Hello and welcome back to e-sipnayan. For today's video, we are going to discuss how to solve for the score given the area. But before we proceed, do not forget to hit like and subscribe so that you'll get notified once we upload new videos. For this video, we are going to achieve the given learning objective, which is to solve for the score given the area or probability. To start off, we will first recall how to solve for the area, and to solve for the area, we need two things, the z-score and the z-table. The z-score will be solved using this formula, z equals x minus mean all over standard deviation, where x here pertains to the given score, mu is the population mean, and sigma is the population standard deviation. Now, we were able to practice already how to solve for the area or probability given the score, mean, and standard deviation. For this video, we are now going to learn how to solve for the z-score, or particularly the score, given the area or probability. For the first example, given a normal distribution with mu equals 60 and sigma equals 9, find the x value that has 65% of area below it. The first thing that we need to do here is to identify what is being asked. We are tasked to solve for the x value that has 65% of area below it. Recall that x pertains to the score. Given the formula we have for z equals x minus mean all over standard deviation. In this particular case, we are solving for x. Now to solve for x, we need the other values for the other three variables z, mu, and sigma. Luckily, we are given with the mu, which is given as 60, and sigma as 9. The only thing left that we need to solve is z. But notice that in the given, there's no particular value of z. Instead, what's given is a probability or area. More specifically, what's given is 65% of area below. So given this x value that we are looking for, it is described of having 65% area below it. Now let's first try to illustrate so that we know what to do in these types of problems. In this normal curve given, we know that to the left starts the probability 0% until 100% to the rightmost part. In the middle, it's 50%. Since we are given with 65% area below from a specific point, we should be covering 65% of its area to the left, because area to the left also means area below. Now, 65% can be found in between 50% and 100%, but a little closer to 50%. So let's have a marking here. Say, for example, from this point until here, this is where we can find that 65%. And the area covered is area to the left, or the area below this particular point. This is what we are solving for. We know that the x values of the normal curve pertains to the z-scores. So given the area, we can solve for z. How are we going to do that? First, we need to convert the given area to decimal so that we will be able to find it on our z-table. Now, the area of z here is given as 0.6500 in decimal. In percent, that is 65%. We are going to look for its closest area in the z-table. Now, what I have here is just a snip of the z-table, and we are going to search for the area closest to the given, which is 65%, or in decimal, 0.6500. Where are we going to find those areas? The areas will be found here in this portion of our z-table. Now, our goal is to find a value that is the closest to the given 65% or 0.6500. So, of course, we are going to look here for values starting from 0.65. So, we have here 0.61, 61, 62, 63, 64 until we reach 0.6517. So, this is a possible value close to 0.6500, but we cannot be sure unless we get the difference. We can also consider 0.6554, but if we compare it to 0.6517, obviously 0.6517 is closer to 0.6500. How will we know if a particular value is the closest to the given area in the problem? Basically, what we need to do is to simply subtract or get the difference. If we subtract 0.6554 to 0.6500, we'll get 0.0054, which is greater than when we subtract 0.6500 to 0.6517, which will be having a difference of 0.0017. Aside from 0.6517, we can also consider the value lesser than it, which is 0.6480. That's again a matter of assessing which difference will be the lowest or lower. So in this case, if we compare the difference between 0.6480 and 0.6517, 0.6517 will be smaller. Hence, that will be the area closest to the given 65%. Now, since we were able to identify already the closest area, which is 0.6517, we just need to do the reverse process. Given the area, we are going to look for its corresponding z-score. So to its left, we can see the first two digits of the z-score. Then to its right, the last digit must be 9. So the z-score given the area 0.6517 is 0.39. This is now the value of z. Again, this is just an estimate because we cannot find a value that is exactly equal to the given 0.6500. So basically, we are just having here estimate. Now, to solve for x, we are simply going to plug in the values to the general formula. So our general formula is z equals x minus mean all over standard deviation. To solve for x, z will be substituted as 0.39. X will remain as a variable because we are solving for it. 60 is our mu that is given, and also the sigma 9 that is given. Now to solve for x, we are just going to use our algebraic skills to be able to isolate x. So what we can do here is to first cross multiply, and then the next part of the solution would be 0.39 times 9 is 3.51 equals 1 times this expression is still x minus 60. To isolate x successfully, we just need to transpose 60 to the other side, and that will become positive 60. So x would be the sum of 3.51 and 60, which will be having a result of 63.51. Now, our value or the score is 63.51. If you want to double check your answer, you can substitute it back to the original equation, and you should be able to get a z-score that is 0.39. Another example, let's have again mu as 60, sigma as 9. We are now going to solve for the x value that has 45% of area above it. Now, we are going to do the same procedure, but notice that we are tasked to solve for the value of x given 45% of area above it. Now, this is slightly different from the previous case because in the previous case, we were solving for the area, or we were solving given the area below. In this case, we are solving given the area above. So let's first try to illustrate the given area here, which is 45% area above. So again, in our normal curve, we start with 0%. In the middle, that's 50%. And on the rightmost part, that's 100%. If we're talking about area above, this is an area that we can describe or illustrate coming from the right. So 45% will be from right to left. That is what we are going to illustrate. So 45% area above will be from right to left, where 0% is here, 50% is still in the middle, and 100% is at the end. So 45% might be somewhere close to 50%. And again, we'll have a marker here. So let's just say this is the z-score that we're looking for so that we can solve for x. So if we try to illustrate the given, 45% area above will be pertaining to this region coming from the right. Take note that in the z-table, all of the probability values given are coming from the left. Now, this is the vice versa. That's why we cannot directly search for 45% in the z-table Because if we look for 45%, we will be pertaining to a z-score that will be found here, and not this one. We want this point or marker, which will represent the given. So for us to be able to know the z-score, we should be considering the area to the left of this particular marker. And how do we do that? We simply need to subtract the given area by 100. So this portion is what we need because the z-table only gives the area to the left. So this will be solved by subtracting 45% to 100, which will give us an area of 55%. This 55% now is the area below, and this will be covering this unshaded region. 55% is now what we are going to use to solve for x and to first solve for z. Now, given the z table, again, we will look for values closest to 0.5500. Now, this is the solution whenever we are given with the area above and we're solving for x. We first need to subtract it by 1. If your answer is in terms of decimals, you subtract it by 100 if your answer is in terms of percent. Now, the area below will be simply the difference of 1 minus the area above, which is 0.500. We are now going to use the z table again, where we're going to find the values here in this portion. I already again snipped the part of the z table and I put it here on the slide. So 0.5500, so let's find the value closest to it by starting to locate the numbers starting by or from 0.55. So we have 0.5517, 0.5557. This is now greater than 0.5517. Let's consider the other value, which is 0.5478. Then determine which is closest to 0.5500. So if we subtract, obviously, the one which will be closer is 0.5517 because the difference is 0.0017. So again, given the area, we can solve or identify what's the value of z. And that will be equal to 0.13. So the z-score representing this portion here or this marker here is 0.13. Then same procedure as a while ago, we are going to solve for x. So that will be simple substitution. Z is what we have identified a while ago, that's 0.13. X is missing, mu is still 60, and sigma is 9. So cross multiply, we'll get 0.13 times 9, that will be 1.17. Then this will be 1 times x minus 60. So we will be copying it because any expression or numbers multiplied to 1 is equal to itself. So to finally isolate x, again, just like what we did a while ago, we can simply transpose 60 to the other side. So that will be x equals 1.17 plus 60. And the value of x or the score will now be the sum, which is 61.17. Now, your key takeaway here is that when you are given with the area above, what you need to do first is to subtract it by 100% or 1 before you can do the procedures that we did as how we solve for the area below. So last example, let's have another one, solving for z this time, given for the area below. Now the given mu is 70, sigma is 7. What's given is 15% of area below it. So in decimal, that's 0.1500. Again, let's just label the parts of our curve in terms of area. 0.1500 or 15% rather will be found in between 0% and 50%, which may be somewhere here. So just a little portion. So let's say this is 15%. We are looking for this z-score that corresponds to this area below, which is 15%. So since it's already area below, we can already proceed with finding the closest value. So the area given is 0.1500. Again, this is just a snip from the z table. So 0.1500 is closest to, let's search for numbers starting from 15 or 0.15. So we have here 0.1587, 1515, and 0.1492. So we are going to compare 0.1515 and 0.1492. So let's try to do it here. So if we subtract 0.1500 by 0.1515, let's get the absolute value so that we'll know the real distance. That will be equal to 0.0015. Meanwhile, if we try to subtract 0.1500 with 0.1492, the difference will be obviously smaller, which is 0.0008. So the value closest to 0.1500 is 0.1492 with a given z-score of negative 0.14. Then same procedure to solve for x. Substitute the values, then isolate x. The value of x will now become 69.02. To summarize the discussion, okay, let's have another example before that. Okay, what if we want the area above? So 15% of area above. Okay, so again, we just simply get the complement. Area below is equal to 1 minus 0.1500, which is 0.8500. This is the value that we are going to locate on our z-table. So again, this is 0%, 50%, 100%, and 15% of area above will be somewhere here. So if this is 15%, the remaining portion is 85%. We are looking for this particular z-score here, which will be having 85% of area below. So again, we use the z-table. We look for numbers closest to 0.8500. So let's try to do the usual. So 0.8508 we have here, and 0.8485. Obviously, the closer one is 0.8508 with a corresponding z-score of 1.04. Then again, same procedure, plug in the values, then isolate x, solve for x, simplify, and we are going to get the score, which is 77.28. So to summarize everything, if we are tasked to solve for the score, of course, we need first the z-score. And these are the procedure. If we are given with the area below, convert the percent to decimal. Then use the z-table to find the closest value. And lastly, identify the z that corresponds to the selected area. If we are given instead the area above, you first need to subtract the given area from 1 or 100%. Then same procedure as what we did in solving for the area below. Again, these are the steps in solving for the z-score. If you want to solve for the score or x, you need to simply manipulate the formula in such a way that one variable will be isolated. And that is all for this video. Thank you for watching and see you on the next one. Bye!